All right. Hello, class. I'm Nick.
And I'm Michael.
All right, and we will be discussing our capstone project. Let me bring up the PowerPoint. All right. Is it the PowerPoint?
Yep.
Okay. All right. So our capstone project for CE 948. I'm Nicholas. And that's Michael, and we will start. So the project, we will be making an ammeter for an automotive application. Most ammeters are outdated in today's uses in cars. Analog ammeters are a thing of the past. The measurements are low precision and they do not use LED screens. They use a pointer system on the old ammeters.
So we propose to make an ammeter using a digital display, an LED pixel digital display with a bar graph that shows your current usage in relation to your alternator capacity. We also propose that we're going to store the data in non-volatile memory so that you can use it in analytics later, and hopefully determine a failing alternator before it fails. Ours will also have accurate measurements, which I think is the most important part.
Yep. All right. So there are similar solutions to this problem, but most of them are outdated, as we said before. Usually their measurement instruments are imprecise nowadays. There are no ammeters on the market today that display bar graphs that will have the max available current drawn like we propose. And there is also no ammeters on the market that store data for later use, as we also propose. Oops. So this is a outdated ammeter model. This is what you typically see in old cars. And all
right. So the idea came from I'm building a Jeep for off-road use, and I'll need one in there because I'll have high power audio equipment and lights and all things like that. People that I've seen in the off-roading world either carry a spare alternator with them or replace it after before they go out every time, which leads to a lot of waste and a lot of headache for very little reason.
The important to us is that it's one of our last projects as students as we transitioned to engineers with our degrees. We get to show everything that we learned throughout all the classes and we get to build upon it. We get to create something different than any other available ammeter on the market. Expansion, we could possibly expand it to include voltage and temperature monitoring down the line. And or we could expand it to a full alternator monitoring system that could detect alternator failure in a car so you know when to change it or swap it out.
The marketing requirements for this, it needs to be easy to use, needs to store the measurement data, needs to measure accurately, and needs to give some mechanism for retrieving that stored data. If we just store it without being able to access it, it's not really useful to anyone.
All right, and this is our objective tree. As you can see, we have the ammeter at the top, and then we have our 4 different marketing requirements. We have the store measurement data, which we will use non-volatile memory to do so. We will have mechanism to retrieve stored data, which is a Bluetooth connection to a device and or a micro SD and or USB port. We wanted to measure accurately we need precision shunt resistors. We need a bad alternator detection in our system and high quantization ADC. We also need the ammeter to be easy to use. We want it to be plug and play. We want the controls to be easy for anybody to use and clear display. So if you're driving fast and it's bumping when you're off-roading, you're able to still see what it's telling you.
So those are needs ranked. You can see from this the accuracy measurement accuracy is the most important, followed by the data storage and the mechanism to retrieve the stored data. The ease of use is the least important in this project.
That is true. All right. So the basic theory behind an ammeter is it is, I guess the basic way to explain it is when we measure current in a circuit, and we have to, when we hook up our multimeters to whatever we're measuring, we have to hook it up in series. So that's basically how an ammeter works. The current inside of a car, the current flows through a coil, and the electromagnetic field around it generates the torque, and the needle moves. As you saw on the picture that we showed you, the needle will move to show you what the current drawn is being used. To do calculations, it's just basic Ohm's law. An ammeter must be connected in series, so as we said, so it won't blow up the ammeter. And to get around this, we can use shunt resistors to measure circuits in parallel if we want to exceed what the ammeter is capable of.
So shunt resistor allows you to measure, like Nick said, allows you to measure much higher than the current a standard ammeter would give you. It divides the measure current instead of not the voltage, and you can have a high power dissipation with a shunt resistor.
And this is an example of what a ammeter and shunt resistors can do. So this is basically like all the different resistors have different ohm readings. So the ammeter has a bunch of different variable of current it can test. If you just, it just would have like some kind of, as it says on the thing, a range selector switch, and you can just switch between each different shunt resistor to change the current being drawn. Oops. Okay. And
Current ammeters are still being done the way we've talked about before, with a permanent magnet with a moving coil. You can easily overwhelm them and break them, especially in the currents that are used in cars. There are some with digital displays, as you can see here, but they're very limited. They don't offer a bar graph or data storage or anything like that.
Yeah, so as we've already said, the current limitations and the similarities between our products is no ammeter on the market will hold non-volatile memory for later, no LED display with graphs of the readings. They still all use the PMMC, which is very limiting, which they can always blow up or break as you're driving. Analog is outdated compared to LED digital. Our ammeter will be digital and not a pointer display. We will have non-volatile memory, and both are designed to measure current drawn on an alternator, but ours will have the LED heads-up display instead.
So this is our problem statement. Like we said before, we need to update our ammeter technology. Our objective is to prototype a digital ammeter that can be easily read and will store data. And the background is our ammeters show critical information when it comes to the operation of, especially off-road vehicles, because they are very power hungry.
Here's our requirement specification. So for the engineering requirements, we have chosen that the measurement accuracy should be at least 1%. This is based on the competitive benchmarking of 1% accuracy should be achievable inside of our ammeter. We should be able to measure current at a frequency of at least 1K hertz. This frequency provides more than enough bandwidth to measure any current spikes that is being drawn or put out through a car as it's driven. The display should show current drawn down to 0.01. This display is enough to show the current drawn down to 10 milliamps, which is more than enough for what our application is needed. The display should have the ability to adjust the brightness from 0 to 100, which is just nice for anybody inside of the car that doesn't want something too bright if their eyes hurt or something. The display should be 0.5 by 3 inches and not greater than 1.5 by 6 inches. This is so the ammeter can fit into any kind of configuration of a car that we set forth. There should be a micro SD port for data storage, and this interface is more than enough to get the data out of the device, which will be able to be used later so you can determine what is going on with your car. And the system should store data at 1 hertz. This frequency provides enough data for analytics. And once again, our marketing requirements, easy to use. We want it to measure accurately. We want it to store data, and we also need the mechanism to retrieve the stored data.
Okay, so this is the engineering and marketing requirements trade-off matrix. So you can see we have our engineering requirements at the top, the marketing requirements on the side, and I mean, you can see the correlation between the different items.
What goes up and what goes down.
Yeah.
All right. And it's the same thing here. This one's just the engineering trade-off instead of the engineering marketing trade-off. You can see the correlation and what goes up and what goes down.
So this is our self-assessment on the engineering requirements. We feel like we've met most of the engineering requirements. There might be more standards that we're missing, especially in automotive application, but this isn't something considered safety critical. So there's not a lot of hard standards to be had with that.
Used, yeah. So for our team building process, we decided to come up with the team name of, sorry if I butcher this, Paiva and Szostek aftermarket ammeters. And and our mission is to design and prototype a digital ammeter for a car that will monitor the current drawn from the alternator. We want this to be new. We want it to be fresh. We don't want it to be what the old things use. We want to make a new product and move on into the future.
So these are our decision-making guidelines. The leader will make all decisions after a discussion, and no one's opinion will be just dismissed. We will consider all opinions.
This will help us since there's only 2 of us that we both have a say when we discuss our opinions and our matters when it comes to our design and prototypes. For the meeting guidelines, we've decided that we will have an agenda before every meeting. We want to meet 4 through 8 times a week. We will always listen to each other's ideas and not dismiss it. Otherwise, we won't move forward. We will record the meeting. So if we ever need to go back and forgot what we said to each other, we can just look it up. And at the end of each meeting, we will agree to what needs to be accomplished moving forward for the week and for our project to be successful.
So our team roles, we decided I'll be the leader, the head engineer, the analyst, and the pessimist. Nick will be the software engineer, the optimist, and the spokesperson.
Yes. And for conflict resolution, we came up that we will always listen to each other about the design and the product and not just brush each other off. We will always identify concerns to each other so we don't get too far ahead and we're like, oh no, this isn't working. Why didn't we talk about this before? And we will always develop a plan to resolve each other's conflict with each other. So we won't butt heads and we can always continue on with our prototype and design. And
So this is our team self-assessment. You can see we're pretty comfortable in our team, I think. We might, I think we feel like there's not too many members on the team. I think overall, I think we're doing all right.
Yeah. All right. So that is our project for our capstone class. Thank you.
Thank you.